everyone, so today we're going to talk about normal distribution and going to be looking at some examples and also how to calculate normal distribution in your calculator. So let's get ready to unlock the power of math together. Let's dive right in. So the graph of a curve is typically bell-shaped and it is symmetric with respect to your mean. So that mean, median, mode are equal and they're located in the center. The curve is continuous and you just want to be aware of that area under that curve is equal to 1 or 100%. And then some just real life examples of sort of normal distribution are like IQ tests, baby birth weights, height. So majority of people are going to be sort of in that middle or that, on average, let's say height. And then of course you're going to have people that are taller and some people that are shorter. So if you think about normal distribution, we kind of use this rule to help you to find some approximate probability. So these are all probabilities. About 68% are going to be in that area that is between one standard deviation from the mean. About 95% of that area is going to be between two standard deviations. And then about 99.7% of that area is going to be within 3 standard deviations. So let's say you have percentages other than these 3 that are provided. You can use your calculator to help you to figure out what that standard deviation is away from the mean. So we're going to look at this question. It is about the level of cholesterol that is in the blood. You are given information as well about 14-year-old boys, and you are given their mean of 170 milligrams and their standard deviation of 30. You will use 2 different calculator commands based on what you are given. So if you are given values on the x-axis, so those x values, those numbers, you're going to be using normal CDF. And that's, again, to help you to find that area or that probability that's under that normal curve. And if you are given a percent, you're going to use inverse norm. That just, again, helps you to sort of work backwards to find your information. Now, in this question, you are asked to find the percent of 14-year-old boys that have more than 240 milligrams per deciliter of cholesterol. So again, you have your mean, which is 170, and then you are looking at more than 240. So then we're looking 240 to the right. So what you are going to do, because you are given an x value, you are going to use the normal CDF. And what you're going to do is first you are going to put that sort of lower number, which is the 240, that's kind of your minimum. The upper number is, again, we don't know what that end number is for that upper value, so we're going to put infinity. And then you are going to put your mu, or your average, which was 170, and then you are going to type in your standard deviation, which was 30. Now, we don't know what number we're going to put in for infinity, right? So a lot of times you could just put in like 1 million, just some very big number that will work in your calculator. So now what you're going to do is you're going to have to click on second and then vars, and then of course you would click on either number 2 or number 3. So again, because we're doing normal CDF, we're going to click on number 2. Now the answer that you get would be 0.0098, but again, as a percent, we're going to multiply by 100 and we would get 0.98% as our answer. Okay, so now we're going to look at the proportion of 14-year-old boys that are going to have less than 150. Of course, we're looking 150 and then below that number. Again, you're given those numbers on the x-axis, so you are again going to use that normal CDF. So when we type this in, you are going to think about what's the lower number. Now, of course, we don't know that lower number. It could be any number, so we're going to just write negative infinity. You do have an upper number, which was the 150. And of course, we're using the same information throughout this problem, which the mu was 170, and the standard deviation is 30. Now, when you again plug this in, you don't know what negative infinity would be. So again, just some big number. You could just say negative 1 million. That would suffice. And then when you get your number, you have 0.252. So again, when you're looking at proportion, again, that's a number. You can literally write this as a fraction. So proportion also just still means the number. Now, in this question, you are going to be looking at cholesterol levels that are between 160 and 180. Now, again, values on your X, you are going to be using number 2, which is the normal CDF calculator option. Now, with this question, your lower value, we know it is 160, and the upper level we know is 180. Still going to use that 170 and 30 from the problem. Now, as you type this in, what you're going to get is you're going to get 0.261. But again, looking at your problem carefully, you're asking how many. Now, this question is giving you that number, which is, again, like a probability. So because you are expecting, right, to be able to figure out how many are going to be between 160 and 180, you are going to take this probability that you just found, and we're going to multiply it by the number of boys that we are looking at. Now we've got 350 boys, and then what we're going to do is we would multiply that, again, that probability times the number. Now that would be the expected value, which is 91.35, and again, we're going to just round, as we know we can't have 0.3 of a student. And then we are going to have 91 students. Again, you can think about this. This is probability times your total number to get that expected number. So another way you can think about it is if 26%, right, because this would technically be your percent, if 26% are expected to be there, now 26% of the 350 students we're looking at would be kind of in this level between 160 and 180. Now, in this question, it looks a little different. We're given a percentage. So what we're going to do is that should be a hint for you that you are going to use the inverse norm. Now, what we're doing is we're sort of making, again, that bell-shaped curve. And what we're doing is we are technically looking at sort of this 20% at this particular level or sort of at this particular value. Now, there are two ways that you can do this question. If you have not a CE calculator, when you type in number 3 in an inverse norm, you actually can't choose if you're looking at the left, center, or the right tail. So what you would do is you would take the inverse norm, and what you're going to realize is that you're actually going to use the area, right? So we're going to use the area here, and then of course we're putting our mean and our standard deviation. So the area that we're looking at is this entire area right here. So when I look at that area, which is 0.08, because I'm looking at the upper 20, that value that I found is going to give me the information at that upper 20% level that I am looking at. So I'm going to take that 0.8, and then again, I'm going to put that same information, the 170 and the 30, when I'm doing the inverse norm. So the answer that I would get would be 195.249. Now, if you have a CE calculator, an 84 CE, you actually can choose the tail, right? You can choose left, right, or center. So because we're looking at the upper 20%, this is how you would type it in. You would say that the area that you're looking at is the 0.2, so it's 20%. Again, you're going to type in the mu and standard deviation, and then you're going to be able to choose the tail because you're looking to the right or the upper 20%. And the answer that you would get would be the same answer as what we just found. Okay, In this question, we are looking at the middle 50%, and it is between two specific levels. So what we're going to have to do is we're going to just need to do inverse norm twice. Now, again, if you are not able to choose, you're just going to do these two numbers so you can get all your information. Now, you're going to have to do sort of that lower area, right? So this lower area here, which is where that 25% is. So we're looking at that 25%. So the 0.25. And then you would have to do the 75% or the 0.75, which would again give you this whole area here. Now, doing this will give you those two values that kind of give you that middle 50%. So it kind of gives you the lower end and the higher end, or the lower number and the upper number. Again, being able to do the 170 and the 30. Now, when you get your two values, you're going to get 149.765. And then the second value you are going to get is 190.235. So again, you're just going to have to do this twice, but you'll still get the same answer. So with choosing option number 3, again, some of you will be able to choose sort of the tail that you're looking at. So you would still do the same sort of process. You're looking at the middle 50%. So the area that you are choosing is the 0.5, and then you're going to be able to choose the center. And then when you type this in your calculator, you get the exact same numbers here. There is just a space between those numbers. So now we're going to talk about z-score, and the z-score is just going to be able to tell you the direction and the number of standard deviation that an observation is from the mean. There is a way for you to calculate your z-score, which you're taking whatever that data value is, subtracting the mean, and then dividing it by the standard deviation. If you were to, again, standardize this normal distribution, again, if you got 10, 10, and going right, 20 in either direction, that is one standard deviation. If you're looking at going 40 in either direction, that would be 2 standard deviations. So again, we're just standardizing our normal distribution here. So here we're going to look at Juanita, and she earned an 82 on her chemistry test. So that's your data value. So that's your X, where the distribution of the scores had a mean, so there's your mu, of 76 and a standard deviation of 4. So now we can find the z-score. Now the z-score is the 82 minus the 76 divided by 4. And when we simplify that, we get 1.5. And then for pre-calc, got an 86. There's our data value. The average, there's our mu for 80, standard deviation of 6.07. So the z-score would be 86 minus 80 divided by 6.07. So that z-score is going to be 0.988. So now we want to know which test Juanita performed better relative to the class. So we look at the z-scores. And Juanita scored better in chemistry than she did in pre-calc because she scored 1.5 standard deviations and she scored above the class average. So we do want to mention the number of standard deviations as well as whether it was above or below the class average. In this question, we have a mean salary of 4 million and a standard deviation of 6 million. We want to find the z-score of Chris Bryant's salary if he made 625,000. So again, same formula with our z-score. And when we find our z-score, we have negative 0.262. Now the z-score is going to tell us about his salary. His salary was 0.626 standard deviations. And again, we're mentioning that if it's above or below, in this case, it would be below the mean. Thanks for joining me today, Unlocking the Power of Math, one problem at a time. Don't forget to like and subscribe for future notifications on other pre-calc videos. Thanks for watching and have a great day.